So I thought I'd work this problem because it illustrates very clearly how it's important to understand the concepts behind everything, because this is the type of problem that would show up on a test, maybe your first or second test in AP Calculus or College Calculus. And it's not the kind of problem that you've studied how to do. You've studied how to take derivatives, you've studied what the tangent line is, you've studied how to find the tangent line at a point, but this is just kind of weird. We're given the tangent line, and we're given a function that has one piece of the function undetermined, and we've got to figure out that piece to force this line to be tangent to the function. The concept at work here is basically that the tangent line shares two things with the original function. It shares the slope with the original function, and it shares a point with the original function. So I'm sure you've seen this picture about 100 times. The tangent line has the same slope, and it has the same value as f. We're going to have to use both of these to solve this problem. So it probably occurs to you that the first thing you should do is take the derivative. And it probably also occurs to you that you want to set this equal to 4, because 4 is the slope of the tangent line. Now, that makes it pretty easy to solve for k. K then is something like 2x minus 4. Now what? We have to use the fact f of x agrees with the tangent line at this x. How do we do that? We set the two equal. So we have x squared minus kx. I'm going to go ahead and substitute this value in for k. And so that becomes x squared minus 2x minus 4 times x. And that's, again, something we're going to set equal to 4x minus 9. Now, we'll do a little algebra here. X squared minus 2x squared plus 4x equals 4x minus 9. 4x's go away. Minus x squared is minus 9. X is plus minus 3. So, if I went through that kind of fast, you can just pause the video and do the algebra for yourself. That probably isn't a problem. So, this also tells us that if you go back to 2x minus 4, which is our value for k, k is then going to be minus 2 or 10. Now, positive 2 or minus 10. There. What's all that about? How can k be two different things? Well, I'll try to sketch how that's possible. If k is positive 2, then so y is 4x plus 9, and f of x is, we'll say, first we'll do x squared plus 10x, and that's equal to x times x plus 10. So I'll do a really rough sketch. X and x plus 10 have y-intercepts at x and minus 10. So this function looks something like that. And then if I did x squared minus 2x, that's the same as x minus 2 times x. That'll have x-intercepts at 0 and 2. What's the point? The point is 4x minus 9, maybe the sketch is too rough, but 4x minus 9 is actually tangent to x squared minus kx for two different values of k. This is an unexpected result. In the middle of a test, you could be working on this and you might say that you'd made a mistake. But if you really understand what's going on, and you have experience sketching tangent lines and sketching functions, and really thinking about what the derivative means and what the tangent line means, you'll be able to make it all the way through this problem. I would consider this a pretty hard problem. This is the kind of problem that separates an A student from a B student on a test. So doing things like practicing sketching graphs, practicing, when you find a tangent line, verify that it actually is tangent to the function by either a sketch or using a calculator. These are things that your homework doesn't ask you to do. But the good calculus students, the ones who really get it, go that extra distance and think about these concepts to make sure they really understand them. That way they can do a problem like this when they haven't actually practiced this kind of problem. I should fix this. This is actually 4x minus 9. So I know I went pretty fast through this video, but you can always rewind it and pause it and work the simple stuff out for yourself. The main thing I wanted to get across was the conceptual stuff.